everyone, myself Yadagiri, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad, and also I am the faculty of Basic Electrical Engineering. So this course is offered for the computer science students and also the allied branch students of the computer science engineering. So in this course having the 5 modules, that is the D circuit, A circuits and transformers, electrical machines and also the electrical utilizations. So 5 modules, so that we can consider also these 5 modules into the 5 units. So the first module number 1 in the basic electrical engineering is that is the DC circuits. So we need to deal with the fundamentals in the DC circuits and also advanced topics in the DC circuits. Then after that we will discuss in the second module. So the complete details on A circuits, that is a pure resistive network with the alternating source. So pure inductive network or element with the alternating source, and RLC series resonance, and also the 3-phase balanced circuits. So so many things we have to discuss in the A circuits. Next, the third unit in the same basic electrical engineering, that is the transformers. So the transformer working principle, operation, and also the regulation of the transformer losses and the efficiency. So these many things we need to discuss in the transformer. So that is the module number 3. Then I will look into the next module, that is the fourth module. Also we can say the unit number 4, that is the electrical machines. So in this we need to discuss about the all kinds of electrical machine, that is the AC and also the DC. So that is means AC means AC generator and also the AC motors. So these things we need to discuss in this electrical machines. The last one is that is a fifth module, that is the electrical installations. So electrical installation means we need to discuss about in this module, that is a LT switchgear components, that is ELCB, MCB, fuse, earthing, rod earthing, pipe earthing, and also the types of batteries. So these so many things we need to discuss in this electrical installation. So now in this session I am going to give the briefing about the electrical circuits, and after that the electrical network. Then after that we will start the module number 1. So need to discuss about the fundamentals in the D circuits. So first of all, before going to start about the D circuits, first of all we need to discuss about the network. So network, so it's a more frequent term in the basic electrical engineering. So that is simply the network is nothing but it is the interconnection of the various elements, either the any element in the electrical circuits. We can say it is the interconnection of the various electrical components. So various electrical components means that is a resistor, inductor, capacitor, and also the voltage source, and as well as current source. So these all electrical elements are connected in any manner. So that kind of structure is called simply network. If the electrical network having the closed paths, so that corresponding network is called as a simply circuit. So this is the foremost fundamental things in the basic electrical engineering, that is the network and the circuit. Network is nothing but it is the interconnection of the, I mean to say electrical network. It is the interconnection of the various elements, that is a resistor, inductor, and capacitor, and also the different sources, that is the voltage and current sources, connected in any kind of manner. So that corresponding structure is called as the simply network. So if the electrical network having the closed path, so that kind of network is known as the simply electrical circuit. So this is the fundamentals in so these circuits. So in also we need to discuss about, so in these fundamentals, so what does it mean by charge? So before going to involve into the topics, the main topics in the D circuits, we need to discuss again fundamentals in D circuits. So previously we have discussed about the electrical network and also the electrical circuit. So the foremost fundamental in the DC circuits. So the foremost fundamentals in the DC circuit is the first one is the charge we can take. So this is also called as the electric charge. The second fundamental thing is the electric current, or simply we can say current. Electric current. Also we can say current. Then the next one is the voltage. This is the voltage. Then the fourth one is power, or we can simply write it as the electrical power. It is a electrical power. Then after that we need to discuss about the energy. So these many fundamentals we need to cover in the fundamentals of the D circuits. So we have already idea about the network and also the circuits. So once again I am reminding that is electrical network is nothing but it is the interconnection of the various electrical elements, that is a resistor, inductor, capacitor, and also the one more element coming to the picture, that is a memoristor. So and along with this also we can connect to one voltage source or any current source. This kind of structure. I mean, these all elements can be conducted in any kind of manner. That corresponding network is simply called as a electrical network. The corresponding structure is also called as the electrical network. If the electrical network having any closed paths, that kind of network is simply called as the electrical circuits. Then after that, we need to discuss about the DC circuits fundamentals. That is a charge and electric current, voltage, and electric power, and also the energy. So the first we need to discuss about the electric charge. So it is a fundamental, electric charge means it is a fundamental property of the matter. So that causes to experience a force when it placed in electric or magnetic field. Means simply say whenever we need to keep the any kind of charge in the electric or the magnetic field, that will experience a force. So that kind of matter, physical fundamental property matter is called as simply charge. So again, the charge is nothing but it is a fundamental property of the matter that can cause it to experience a force when it is placed in electric or magnetic field. So the charge can be denoted by the capital Q and measured in terms of it is coulombs. So either the charges are two types, either the positive charge and also the negative charge. So in the electrical circuits or DC circuits, more frequently we have to use the negative charge only. So that is we can say electron only. So for that we need to discuss, we need to looking about the mass value of electron and also the charge value of electron. So the charge value of electron, that is 1.602 into 10 power minus 19 coulombs. This is the negative charge magnitude value of the, this is the negative charge magnitude value as a 1.602 into 10 power minus 19 coulomb. That is simply say, so the electron charge value is the 1.602 into 10 power minus 19 coulombs. Then the next one is the mass value of electron. We can also discuss, we can also consider the mass value of electron, that is a 9.11 into 10 power minus 31 kilogram. This is the mass value of the electron. So this is the discussion regarding the charge. The charge is nothing but it is a fundamental property of the matter that can cause us to experience a force when it is placed in magnetic or electric field, and the charge can be generated by the capital Q. Either the charge may be positive or negative. So in the electrical engineering or electrical circuits, we need to consider always about the negative charge, that is electron only. So the mass value we also required. That's why we need to look into the mass value of electron, that is 1.602 into 10 power minus 19 coulomb, and also this charge value of the electron is a 1.602 into the minus 10 power 19 coulombs, and also the mass value of electron is a 9.11 into 10 power minus 31 kilogram. So this is a very fundamental parameter, that is the electric charge simply. The next other fundamental the concept of the DC circuits or electric circuit is electric currents. So the electric current is nothing but it is a rate of flow of charge, or it is a flow of electrons in any kind of conductor or any circuit is called as simply electric current. So we need to also define the electric current, that is it is a rate of flow of charge in any conducting metal or any electrical circuit. Simply we can call it as a electric current. Other words also we can define the current. So that is it is a flow of free electrons in any conducting material or any electrical circuit. So that corresponding thing is we can say electric currents. So the electric current we can denote by either the capital I, also the small I. So here the capital I we can write in terms of the capital Q by T, and the small I we can write in terms of the dq upon dt. So based on the definition, so it is a rate of flow of charge. So it is measured in terms of the charge units are we can say simply coulombs, and the time units are we can simply say seconds. So one current value or the current flow of the any conducting material or any electric circuit is simply measured in terms of the coulomb per second. 1 coulomb per second is also called as 1 ampere. That's why the units of current is either the coulomb per second or simply ampere. So this is discussion regarding the electric current. So then next one is after this one electric voltage. So sometimes this is also called as the potential difference. So the potential difference or electric voltage we can define. So let us take two different potentials. This is a point A, point B, or potential A, potential B. So I would like to bring one positive unit charge from this potential to this potential. So this potential having many number of charges, that is simply say it is an infinite charge. This one is we can say infinite charge. So we need to bring from this infinite potential to one unit charge from this infinite potential to other potential. So we require some force. So that external force is simply called as a, that is voltage. So we need to say in terms of technical words, that is the work done to bring a unit positive charge. That is the work done to bring a unit positive charge from the infinite potential to other potential to require an external force. So that external force is simply known as the electric voltage. So or also we can say, I mean to say, also define the electric voltage in other words. So this is a point A or potential A, this is a point B or potential B. So we need to consider the potential differences between these two potential. That is also called as the electric voltage. That is a VAB. Means the value of voltage across these two points means it's a VA minus VB. So this also we can say simply electric voltage. So the electric voltage denoted by either capital V or small v. So capital V equal to, we can write W by Q. Capital V equal to W by Q, or small v equal to, we can also write it like dW upon dQ. So the unit of W means work done. Work done units are, we can say, joules, and the units of charge is the coulombs. So I'm going to say the unit of the voltage measured in terms of the either joule per coulomb. 1 joule per coulomb is also same as the 1 volt. That's why the voltage of any circuit that will measure in terms of the volt. Volts are joule per coulomb. Means 1 joule per coulomb is also same as the 1 volt. That's why. So this is the unit of the voltage is volts, and the unit of the current is the ampere. So the every unit we can represent by the capital letter, by because it is a scientist name, because the ampere is a scientist name. He was invented the current flow of the material or any conductor. That's why. So we can write in terms of the ampere the unit of the current. Either capital A we need to write, other words we can write the full name. So here are the same. So the units of this one is volts. So next one is, so till now we have discussed about the current and voltage. Next we need to go with the electric power. So electric power we need to go with the, so next concept, that is electric power means. So the electric power, before going to briefing about the electric power, so we need to discuss about the, first of all, what does it mean by general power? I mean to say, so what does it mean by power? So it is a, power is nothing but it is a rate of doing work. Simply, it is a rate of doing work is simply called as a generally power. So the power can be denoted by the capital P and measured in terms of simply watts. So measured in terms of the watts. So here I am erasing this one. So the general power units is a, simply we can say watts. So generally power is nothing but it is a rate of doing work. The capacity doing work is simply called as a generally power, we can say. So P equal to, we can write that is a W by T. So W by T, or we can also write this, that is P equal to dW upon dt, we can write. So the power of any general, either the physics, maybe it is defined from the physics. So according to that, so the power is nothing but it is a rate of doing work. So according to that, we can write that P equal to dW by dt. So the dW means it is a work done. That's why the units of this one is, so joules, and the time, this is the rate of change of time. That's why, so the units of the time is a seconds. So means the power units are, we can consider as the joule per second. Means the power of any general in the physics or anything, we can measure in terms of the joules per second. 1 joule per second is also called as the 1 watt. So that's why we can also measure the, so the power in terms of the watts. So now here the electric power we are going to discuss about. This is a general power. General power nothing but it is a rate of doing work. According to this one, we can measure in terms of the either joule per second, or we can simply say watt. So now we need to discuss about the general power. So here I'm going to do some mathematics regarding the general power. So we know that from the power formula, that is a dW upon dt. So we need to do some mathematics here. So which implies a P equal to, so dW upon dW upon dq, so into dq upon dt. Means what I written means here, so I need to do the above term with the with the multiplication and also the division by the dq. Means I have done here the multiplication and division with the dq. That's why we got the expression is like this. So here P equal to, here we have seen already this one is, so that is a work done. So to bring a unit charge, that is simply called as a electric voltage, and this is the rate of flow of charge, we can simply call it as a electric current. So we got here again electrical parameters. So that's why the electrical power we have to determine from the mathematics, that is the product of the voltage and current. Simply the electrical power can be defined from mathematics, which is defined as it is a product of the applied voltage and currents. So it's also measured in terms of the simply watts. So this is the electrical power. So next one we need to discuss about the energy. So this energy is nothing but it is a rate of doing, sorry, it is a capacity or ability doing work. So it is a capacity or ability to do work is simply called as energy. The energy we can represent in terms of the capital E or W. So this is the energy. Energy nothing but it is a ability or the capacity to do work. That's called simply energy. We can represent that energy in terms of either E or capital W. So then E equal to, we can write into, that is in terms of power, that is a P into T. Also we can write, so that is a integration of P into dt also we can write. So that's why the energy, so we have to measure in terms of the, I mean based on this one, the energy we need to measure in terms of the, so that is a watt second. Means the unit of power is a watt and the unit of the time is a second. That's why it is a watt second. 1 watt second is also same as the 1 joule. That's why the energy measured in terms of either electrical energy or general energy measured in terms of the either the watt second or joules. So this is a fundamental parameters in DC circuits. So based on this one, we need to do the analysis of the all kind of electrical circuits and also the response of individual elements. So whatever we need to do, that we can we can take the help of these all fundamentals. So next one, we need to enter into the first module, first topic. This is the fundamentals in also the first module. So next we need to enter into the main topic of the first unit. I mean the first topic of the first module, that is Ohm's law. So it was invented by the George Simon Ohm. So it was invented by the George Simon Ohm. He has given the relation between the voltage and also current based on this Ohm's law. So we need to we need to get the awareness on the voltage and current. So according to him, it states that, I mean to say, the Ohm's law simply states that at a constant temperature, the current flowing through the any kind of material, connecting material or electrical circuit is directly proportional to the simply potential difference or simply applied voltage. So that is the statement of Ohm's law. So the Ohm's law is simply states that, so that is the current flowing through the any conducting metal or electrical circuit is directly proportional to the simply applied voltage and the temperature remains constant. So this one is some material, so that material offers some resistance or ohms, and also we need to connect one voltage source or one battery to this kind of material that will drive the own current as current. So based on this one, we can say according to the definition, that is I directly proportional to V. Means the Ohm's law is clearly saying us at a constant temperature, the current flowing through the circuit is directly proportional to the applied voltage. That's why we have to write the term is I directly proportional to V. So some standard textbook or some the people are standard textbooks also follow the notation like V directly proportional to Y. That is also correct one. But I always consider the response of the circuit. So that is the current. If I applied the voltage to the circuit, then we got the current. That's why I consider always the I directly proportional to V response. Whatever it is, you can use both are correct only. So from this one, remove the proportionality, you will get the proportionality constant as K into V. So instead of K, I am going to represent this K as the G, capital G. Both are same only. Where G is the proportionality constant. Where G is the proportionality constant. And also this one called as, it is a conductance of the material. And also called as, it is a conductance of the material. So the conductance of the material is nothing but which conduct the electric current or which conduct the electron flow in any material or any conducting material, that's simply called as conductance. So that's why we can represent the G as a conductance of the material. So then we can also write the G in terms of the other words, that is a reciprocal of the resistance, also called as simply G. Means it is a 1 by R. So then we keep as this, so that we'll get the I equal to V by R. So this we got as I equal to V by R. So from this one, V equal to IR, we got this the voltage drop across the, so this particular material or this particular resistive element. So this is the statement and explanation regarding the Ohm's law. So it is a sensitive on temperature. That's why there will be a certain limitations are there for this Ohm's law. So the first and foremost, the limitation is it's only purely applicable for the linear elements only. So whatever the elements, the VI graph should be passes from the origin and also obeys the property of Ohm's law. Means the voltage and current relationships are directly proportional to each other. So that's why, so that kind of elements are called simply linear elements. So it is depending on temperature. That's why based on that there are certain limitations are there for Ohm's law. The first and foremost limitation is it is purely applicable for linear elements. So the linear elements are such as a resistor, inductor, and capacitor. So these are the three elements. So we have to use it in the linear category. So next point are the next limitation, it is not applicable for non-linear elements. So it is not applicable for non-linear elements. So whatever the elements are doesn't obey the property of the voltage and current relationship. That is a direct relationship between the voltage and current. Those kind of elements are simply called as the non-linear elements. So the best example of this one is a PN junction diode, then silicon controlled rectifier, then a transistor, etc. So these so many elements under the category of non-linearity. And also the Ohm's law not applicable for depending on the temperature means it's also not applicable for metals. So Ohm's law is also not applicable for metals, and also it's not applicable for neon lamps. Not applicable for neon lamps, and also it's not applicable for vacuum tubes. So vacuum tubes, and Ohm's law is also not applicable for gas filled tubes. So the gas filled tubes nothing but all kinds of indicators, gas filled tubes. So these are also the certain limitation. These applications also under the limitations of Ohm's law. So this is example of this one is the indicators like electrical indicators. So these are all under the category of gas filled tubes. So these limitations are there for Ohm's law. So based on this condition, we can also use this Ohm's law in. So Ohm's law used in the first and foremost thing is electrical power system. So we have to use the Ohm's law in the electrical power system to analyze the required power calculations. That is electrical power systems, and also the electrical machines to analyze the machine characteristics and performance by using the Ohm's law only. That's why we can also use in electrical machines, and after that also use it in the communication system. So communication system also we can use the Ohm's law to analyze the things, and also aerospace engineering. Also we can use the Ohm's law to get the required parameters, and also the satellite communication, etc. These are the applications of the different applications of the Ohm's law. So based on their analysis. So this is the foremost and fundamental concept of the first method, that is the DC circuits. In this session till now we have discussed about the fundamentals in the DC circuits. So that is the voltage, current, power, and the energy. And also they discuss the Ohm's law. So Ohm's law and its limitation, and also the applications of Ohm's law. So based on this one, the Ohm's law is applicable for each and every linear elements. So to obtain the voltage drop across that particular elements, and there are certain limitations there for Ohm's law. That is, so based on the element material. So the first one foremost limitation is that it is only applicable for linear elements, and it's not applicable for non-linear elements, and also the metals, and also the vacuum tubes, etc. So in the next session we will discuss about the fundamental elements, that is R, L, C means resistor, inductor, and capacitor.